Hello students, how are you? I am assistant professor Karan Kumar Das, come back again. And yesterday we have studied up to the alkylation within the chemical properties of the alkene. So today we will start the hydroboration of the alkene. So what is the hydroboration? Hydroboration means one alkene reacts with the diborane in presence of the aqueous alkaline solution of the hydrogen peroxide. What is diborane? Diborane means B2H6. Okay. So here I have given the example, hopefully you have seen it, given the example of the propene which reacts with the diborane in presence of the alkaline hydrogen peroxide solution and forming the primary alcohol 1-propanol. So what is the hydroboration? Hydroboration means one alkene reacts with the diborane in presence of the aqueous alkaline solution of the hydrogen peroxide and produces the primary alcohol. Okay. And remember one thing, it is obviously follow the peroxide effect, that means the anti-Markovnikov rule. It follow the anti-Markovnikov rule. Okay, it is the against of the Markovnikov rule, that means it follows the peroxide effect. Okay, next one, it is one of the most important question. It is also known as the Bayes test. Which is Bayes test? When alkenes react with the cold potassium permanganate solution. When alkenes react with the cold potassium permanganate solution, it is converted to the glycol. Okay, this procedure is known as the Bayes test. Bayes test is very important to identify the double bond, that means the alkenes or triple bonds. Any compound contains double bond or triple bond, yes or no, that has been determined by the Bayes test. Okay, so what is the Bayes test? I have given here you the two example. First example, in case of the ethylene when reacts with the cold potassium permanganate solution, it is converted to the ethylene glycol. Okay, and when propylene reacts with the cold KMnO4 solution, it is converted to the propylene glycol. It is known as the Bayes test. Your question will become, write a short note on the Bayes test. Okay, but what is Bayes test? In question of the MCQ, the question correct answer will be when alkenes reacts with the cold potassium permanganate solution, and it is very much useful both for the alkene and alkyne. In when we have studied the alkyne, then you have found this point also, the Bayes test. Clear? But it is the cold solution of the potassium permanganate. What happens when any alkene reacts with the hot potassium permanganate solution? Yes, at that time our next point will be that the oxidation of the hot potassium permanganate solution. The oxidation of the hot potassium permanganate solution. At that time what will be happen? One acid and or one ketone. And or means one acid either or one acid and one ketone. Both will be formed. Then I have given the two examples. First example, in case of the propylene, when propylene reacts with the hot potassium permanganate solution, at that time it will be forming only the acetic acid. But in case of the 2-methyl-2-butene, it is forming one acetone and one acetic acid. Clear? So it is the oxidation of the hot potassium permanganate solution. Next point, that is the catalytic oxidation. Catalytic oxidation means when alkenes reacts with the oxygen at the temperature of the 250 to 400 degrees Celsius temperature, and silver is used as the catalyst. Okay, alkenes react with the oxygen in presence of the silver catalyst along with 250 to 400 degrees Celsius temperature. At that time, epoxide has been formed. Okay, here I have given one example for you, that is the ethylene. It is ethylene. Ethylene when reacts with the oxygen in presence of the temperature and along with the silver catalyst, the ethylene oxide has been formed. Okay. Next point, oxidation with ozone. Oxidation with ozone means alkenes reacts with the ozone first step. How? When ozone gas is passes over alkene, it forming the ozonide. And remember one thing, the alkene must be present in any inert solvent like the carbon tetrachloride. Okay, the alkene must be present in any inert solvent and ozone gas passes through the alkene, then alkene converted to the ozonide. See here I have given the example of the ethylene. When ethylene reacts with the ozone, it forms the ozonide. Okay, it forms the ozonide. This is the rough structure of the ozonide. Okay. Next step, if the ozonide is warming with zinc and water, then ozonide is converted to the carbonyl compound. Okay, here the end product will be the formaldehyde. And these two process, that means its overall process, first alkene reacts with the ozone and forming the ozonide, and ozonide again reacts with the zinc and water, then finally forming the carbonyl compound. The overall process is known as the ozonolysis. Okay, and this process is the very much important to detect the position of the double bond in an unknown alkene. Okay, any unknown alkene, what is the position of the double bond? To detect the position of the double bond, this ozonolysis process is the very much important. Clear? Your exam question will become, what is the significance of the ozonolysis? Okay, then your answer will be to detect the position of the double bond in an unknown alkene. Okay, if their question will become, write a short note about the ozonolysis, then you are liable to write the two steps. First step, alkenes react with the ozone gas in presence of an inert solvent, and next step, the ozonide reacts with the zinc and water. Okay, this two steps togetherly called as the ozonolysis. Clear? Next we will study the combustion. Combustion means when alkenes reacts to the air directly. Air means to the oxygen directly, then it is converted to the water, carbon dioxide and some heat also. Okay, here I have given the example of the ethylene. Okay, when ethylene reacts with the air, that means the oxygen directly, it is forming the water, carbon dioxide and heat. Clear? Next is the polymerization. Polymerization means what? Polymerization means conversion of any small molecule alkenes to the large molecule. Okay, conversion of the any small molecule alkenes to the large molecule of that particular alkenes, that is known as the polymerization. And to continue this process, either sulfuric acid or hydrofluoric acid or any organic peroxide is required as catalyst, and sometimes external pressure and temperature is also required. Clear? This process is known as the polymerization. Here I have given the example for the ethylene. Okay, when ethylene are totally appearing for the polymerization reaction, it is converted to the polyethylene. Okay, now the last thing of the alkenes chemical property, that is the allylic substitution. What is the allylic substitution? Allylic substitution means the substitution of the alkenes by halogen. Okay, when alkenes is heated with either chlorine or bromine. Okay, when alkenes are react with the either chlorine or bromine, and hopefully you know both chlorine and bromine both are the halogen. So when alkenes are react with chlorine or bromine, then what will be happen? One allyl hydrogen will replaced by the one halogen atom. And what is the allyl position? Allyl position is that carbon position which carbon is the adjacent position of any unsaturated carbon atoms. That means, see here, don't be confused, see here, just here I have given example for the propene. Okay, when propene is heated at the 500 degree Celsius temperature, then with the chlorine, then allyl chloride